question here, find the 6 trig values of the point 45. Let's find the 4.45. It's there. Up there. Let's get the right pen, of course, that would help. So 4, 5 is there. What we do now, we draw a triangle. We draw a perpendicular down to the axis, across to the origin, like that. You've got to make sure you draw your triangle correctly each time. We know that this distance along the baseline is 4, and we know that that is 5 going upstairs because the point is 4, 5. Now by Pythagoras, let's work out c. C squared equals 4 squared plus 5 squared. So 16 plus 25 equals 41. So C equals root 41. Now we talk about doing the 6 trig values. Well, the angle we're interested in is in this one here. It's the angle to the horizontal the whole time. So it's this one here. It's just so we can colour it in red. That's the angle we want. And we're going to go for sine of x. We'll call it x degrees. Now we're looking at SOHCAHTOA here. So we want SOHCAHTOA. And we know that sine is opposite over hypotenuse. So the opposite is going to be 5 to that red angle, and the hypotenuse is going to be c. So 5 over root 41 is the sine. You need to multiply by root 41 over root 41 to get rid of that radical, and we get 5 root 41 over 41, because root 41 times root 41 is 41. Cos x, let's go to the next SOHCAHTOA, is adjacent over hypotenuse. So we know the adjacent is 4, and the hypotenuse is root 41, so it's going to be 4 over root 41. And if we follow the same process we did before, it's going to be 4 root 41 over 41. Tan x is going to be opposite over adjacent, so 5 over 4, that's easy. Now what does it mean by the 6 trig functions? Well, each of these has a reciprocal. So the reciprocal of sine is cosec x. Cosec x, and we write it CSC. And all we do is turn this one upside down. Well, that's a bit tricky. Much easier to turn this one upside down. So root 41 over 5. So cosec is 1 over sine x. The reciprocal of cos is sec. And sec x. Turn this one upside down. Well, it's much easier to turn this one upside down. So root 41 over 4. And then the reciprocal of tan is cotangent x. We call it cot x. It's going to be this one turned upside down, so 4 over 5. So the point negative 4, 2. Negative 4, 2 is over on the left-hand side here. Just going to get a point, get the right colour. So negative 4, 2 is there. I'm going to make sure now we get the right triangle. So the triangle is going to be horizontal, vertically down to the axis, then across to the origin, and then the hypotenuse is going to come down there. So we know that this length here is negative 4, and the vertical height is 2. Pythagoras would give you c squared equals negative 4 squared plus 2 squared, which we know is 16 plus 4 is 20. So therefore c, the hypotenuse, is going to be root 20, which is 2 root 5. Okay, and now we've got to find out the 6 trig functions. So we know that sine x is opposite over hypotenuse, so the opposite side is going to be here, and the hypotenuse obviously there. So it's going to be 2 divided by 2 root 5. Those 2's will cancel out, and we get 1 over root 5. And we rationalize the denominator again by root 5 over root 5. And the top becomes root 5. 1 times root 5 is 5. And the bottom is 5. We come on to cos x. We get the adjacent negative 4 there over the hypotenuse over 2 root 5. And again, the 4 and the 2 will reduce, and we get negative 2 over root 5. And we multiply by root 5 over root 5, and we get negative 2 root 5, and root 5 times root 5 is just 5. Tan x is going to be opposite over adjacent, so 2 over negative 4 equals negative 1/2. Now the reciprocal functions, well, we know that cosec x is the reciprocal of sine, so if we turn this one upside down, it doesn't matter which of these 3 we turn upside down, we'll get the right answer, and we get the answer root 5. Sec x is the reciprocal of cos, so we can turn this one upside down here, so negative 5, negative root 5 over 2, that negative sign can go anywhere, and cotangent x, which is the reciprocal of tan, we can just turn this one upside down, negative 2 over 1 is negative 2. Interesting enough, we talk about the x here, which is the x value here. We know that we talk about this radius arm that rotates, so there's the angle that this line has moved through since being at this point 0, so it's moved through this distance here. So that angle there is what we call, say, theta. This angle in here is the interesting one for the triangle, and that's the one we call x. These two, x and theta, because they're supplementary, they add up to 180, are linked. But there's always the angle inside the triangle that we deal with, the red angle there, but it does refer to obviously the one that the line has moved through. Okay, find the 6 trig values of point negative 3, negative 4. Well, let's find the point negative 3, negative 4 first. Negative 3 on the x, negative 4 on the y is down there. So straight away we draw a line straight to the origin, then a vertical line to the axis, and the triangle looks like that. This length is negative 3, this length is negative 4 to give that point there. If we do Pythagoras, we get c squared equals negative, that's wrong, excuse me, negative 3 squared plus negative 4 squared. That gives you 25, 9 plus 16, so c equals 5. So the hypotenuse here is 5. And therefore we go through the ratios, sine x equals opposite over hypotenuse. Okay, which is the x? Well, this is the angle. This line has moved through this angle here. The x is this angle in here to the horizontal. So that's the angle x we're talking about. So sine x equals opposite, which will be negative 4. That's what I'm doing here. Negative 4 over the hypotenuse 5. That will be the sine, negative 4 over 5. Cos x will be the adjacent side, negative 3 over negative 5. And tan x will be opposite over adjacent, so negative 4 over negative 3, which is 4 over 3. The reciprocal function, so cosec x is reciprocal to sine, will be negative 5 over 4. Just basically turn this upside down. Sec x is the reciprocal of cos, So negative 5 over 3, and cot x is the reciprocal of tan, so 3 over 4, turning this one upside down.